Good morning, everyone. I'm Samarjeet Singh Khera from Acropolis Institute of Technology and Research in Indore, and today I'm going to discuss about the methods of machine learning in big data in the following slides. Now, as we all know, with the rise of ChatGPT, Bard AI, and various other generative AI bots, machine learning is all the rage right now. But machine learning has been employed in the field of big data analytics for a very long time. That is because of the sheer velocity, variety, and volume of big data. We are going to discuss about in detail in this entire section. Now, first of all, let's discuss about what is big data. Well, big data can be described as the data which is so enormous, versatile, and dynamic that the traditional data processing and data analytics technologies are simply incapable of processing or storing it. In order to work on various data, we need to employ special technologies that can only be used on it. Now, these technologies vary from Hadoop, Pig, Hive to various machine learning technologies. Now big data can be characterized by five V's. Now these V's are volume, velocity, veracity, and value. We are going to be discussing about all of these five V's in the next slide in extreme detail. Now, since we have learned about what is big data, now discuss about the five V's which are inherent to it. The first V of big data is volume. It is the most important attribute of big data. Nowadays, since data is flowing from everywhere, it can include from simple clicks on websites and social media posts to information collected by various IoT devices. Due to Due to this large amount of data flowing, it becomes nearly impossible for traditional databases to store it. So to store big data, we need to employ special methods. Now the next V, which is inherent to big data, is velocity. As we have discussed earlier that big data is streaming very fast from various resources. So in order for an organization or research institute to make some sense of it, it is required that this data is also used at a very fast pace because this data can become outdated or irrelevant very quickly. Now, the next trait of big data is variety. Now, big data can be of three types: structured, unstructured, and semi structured. Structured data can be obtained from various other small databases. Semi-structured data can be obtained from in various forms like JSON or XML, which is widely used in communication between APIs. And unstructured data can be of the form of visual, audio, or user-generated text. So it is important to process all of these varied types of data. Now, the next trait that big data has is veracity. Veracity refers to the quality and accuracy of big data. Now, the gathered data could have some missing pieces. It may be accurate or it may not provide the real or valuable insights which we may be looking for. Thus, big data can lack overall trust. So, in order to make this trustworthy, we have to employ various resources. Veracity is important because in fields like aviation or medicine, the trust on big data is extremely important. Now, the fifth and the last V that is inherent to big data is value. Now, without value, all of the other four V's are irrelevant because if we have obtained big data, then it has to provide some value to the concerning organization or research institute. Otherwise, all of these big data collected is can be considered useless. Now, as we have discussed in the five V's, that big data has some very interesting and valuable inherent qualities, but these qualities also provides us various challenges. Now, the first challenge that big data provides is storage. Since big data can't be stored in simple and traditional SQL or NoSQL databases, that's why in order to store big data, we need to have scalable database solutions. That's why storing in cloud clusters is the best bet for working in big data. Now, the same problems are also encountered when it comes to processing and analyzing big data because the data streaming is just so continuous. That's why we need to employ Hadoop and various nodes in order to process and analyze big data. Now the fourth main challenge of big data is the quality. Now the big data, as we have discussed in the veracity point, it can be highly inaccurate. So in order to make good decisions, we need to have a finely tuned big data. Otherwise, we might land up at the wrong decisions. So in order to overcome these challenges, machine learning is a very valuable resource since machine learning does not require manual labor which can take a long time. Machine learning can analyze and process big data in extremely fast way and it can also keep up with the constant stream of big data. Now the fifth and the another emerging major challenge with big data is data security. Now, as we have heard a lot of times in news that data breaches in various big organizations has become very common nowadays since since the hacking and cybersecurity community is becoming more and more advanced. Recently, it has been reported that the government of India had a major data breach in which the Aadhaar card information of through COVID vaccines have been floating on dark web. So security has been given extreme priority nowadays in big data, and we have to overcome these challenges. Now let's talk about machine learning. So first of all, what is machine learning? Well, machine learning can be said as a branch of artificial intelligence that focuses on developing models and algorithms that let computer learn from data and improve from previous experiences without being exactly or explicitly programmed for each and every task. In simple words, it can be said that machine learning teaches the system how to think on its own and understand from its learning just like a human do. So machine learning is generally used for training from past experiences and improving over time. This can be extremely beneficial in big data. Why you ask? Well, because it can automate various tasks for analysts, making their work extremely easy. And it can also help in unlocking insights which could have been left out by a human analyst. Now, it is also very important that in order to work with various types of big data, we choose the right type of machine learning and algorithm. Since nowadays each organization is trying to become data driven as it is a more objective view to look at various problems arising in industry, thus choosing the right method for machine learning is extremely important. Now let's discuss about the various methods of machine learning in the next slide. Now, there are several methods of machine learning, but these methods can be divided into these five main types, namely supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning, and deep learning. All of these all of these methods comes with their own characteristics, applications, advantages, and disadvantages. These helps us in making predictions in different ways and each have their own unique characteristics. Now let's discuss about each of these five methods one by one. Now, the first method of machine learning that we are going to be discussing today is supervised machine learning. Now, supervised machine learning can be understood as a knowledgeable instructor or teacher guiding our hand. In supervised machine learning, a model gets trained on a labeled dataset. Now, what is a labeled dataset, you may ask? Now let us consider an example of image classifier. Now let's say we are building an image classifier that differentiates between cats and dogs. Now in order to train this model, we will feed it with the labeled datasets of cats and dogs. Now after a certain period of time, the model will automatically identifying the new cats and dog images based on the previous input. Now these two new images will be so such that it has never been input in the data set, but still the model will accurately identify it. That is the power and beauty of supervised machine learning. Now since the data set which we are feeding in this method is labeled, that's why it can be extremely tedious and resource intensive to provide such data sets. That's why if we do not have resources or money available, this supervised machine learning method is not employed. Now this is mainly employed in image classification, in which we have to classify various images, or sentiment analysis, in which we have to determine the sentiment of a certain text, or in predictive analysis such as forecasting, sales forecasting, or or where the batsman is gonna hit the next ball. Now, the benefit of this supervised machine learning model is that the model has a clear relationship defined in it between the input and output. That's why it is extremely valuable if we are dealing with structured data sets. Now let's discuss about the next machine learning method, that is unsupervised machine learning. Well, in unsupervised machine learning, the relation between the input and output is not clearly defined. In this machine learning method, we do not feed machine learning labeled data. Instead, we feed it unlabeled data. This machine learning method is extremely valuable if we have to discuss the unique patterns or relationships between data. It is valuable if we are building a recommendation system, or we have to cluster data in various sets. Now let us consider an example of unsupervised machine learning. Now let's just say that we input our purchase history from e-commerce website to unsupervised machine learning method. So through unsupervised machine learning, it will cluster us with various other users and help the company identify that, alright, so which group of customer is likely to buy which kind of product. Thus, it is also valuable if we are detecting an anomaly. For example, in a finance, if let's just say suddenly a user starts making a kind of purchase which are uncharacteristic to its previous history. Thus, in that cases, the machine learning method will immediately classify anomalies. Thus, unsupervised machine learning is extremely useful in the field of big data. Now, the main methods which use unsupervised machine learning is k-means clustering and PCA. It is also helpful in order to label and classify data. Now let us discuss about semi-supervised machine learning method. So semi-supervised is a machine learning algorithm that works between supervised and unsupervised machine learning. So the data that is input in this method is both labeled as well as unlabeled. It is particularly useful when the obtaining a data set which is labeled is extremely time consuming or resource intensive. It is also used when the data set is expensive and it requires a certain amount of skill to completely label or process it. In those cases, semi-supervised machine learning can be a boon. Now let us consider an example. Let's just say we are building a language translation model which translates language from English to Hindi. Now, it can be extremely resource intensive if we try to to input data about translation of every English sentence to Hindi sentence in it. Since there are thousands, if hundreds of thousands, if not millions of translation. Thus, if we input some data sets, so it can easily identify the pattern and and can generalize that alright, so this is how the language works and this is how I can translate these new sentences. Thus, it can be said that it is a generalization of supervised machine learning. Now, it is helpful in language translation, object recognition, or natural language processing. It is also behind various chatbots, including ChatGPT and Bard AI. It leverages the limited label data that we have and works with that abundant unlabeled data and generalize it better so that it can although that later supervised or unsupervised machine learning models can also be used in it. Let's discuss about our fourth machine learning method that is known as reinforcement machine learning. Now, the motto of reinforcement machine learning is trial, error, and delay. So, what happens in this machine learning model the is that by trial and error, the model on its own determines that what is the ideal behavior within a specific context in order to maximize the performance. Now, the most important example of reinforcement machine learning is a AI chess player. Now this AI chess player can explore different moves and receive positive and negative feedback on the outcome. Thus, over time, it can become an extremely accurate chess playing bot, which can defeat even the best of players since it always knows all the possible outcomes and where all the dead ends are. Now, the advantage of reinforcement machine learning is that it is well suited for tasks in which we have to make a sequence of decisions like complex games like Go, chess, shogi, and can also help us in achieving long-term results of various complex problems, which we cannot do by conventional means. However, the main disadvantage that reinforcement machine learning has is that it is extremely computationally extensive. We have to put a lot of time and resources in order to train the reinforcement machine learning model. Reinforcement machine learning model is based on this English concept of reinforcement in which we try to chip away all the unnecessary bluff and reinforces our model again and again to make it even stronger. Now the main algorithms that supports reinforcement machine learning are deep Q networks and Q learning. The reinforcement machine learning algorithm is also heavily employed in game playing and self-driving cars. Now, deep learning algorithm is one of the most interesting machine learning methods since it uses the most complex neural networks out of all of these. In deep learning algorithm, the neural networks employed have multiple layers. It is so that it can easily identify complex patterns and representations among data. A deep learning method is based on the concept that we try to make our neural network replicate human brain so that it can be used in complex fields like image and speech recognition, natural language processing, or in medical and aviation, since in those places we need to have extremely accurate results. Now, in deep learning, we mainly use two types of neural networks. First is convolutional neural network, which is used for image processing, and the second one is recurrent neural network which we use for language processing. The deep learning method excels if we are handling unstructured data and we have to break through in uncharted territory. In those territory, AI can make such resources, such discoveries that can change the entire field. In fact, recently, deep learning has identified various new diseases by looking at medical imageries and expanded our knowledge on cancer tissues. Thus, if we have to find cure of complex diseases like cancer, TB, or AIDS, which have not been identified since now. So deep learning while resource intensive is the ideal machine learning method in those fields. Now, machine learning can be employed in real world applications. The five fields in which machine learning is extensively being used are mentioned here. First is healthcare. In healthcare, as we have discussed in the deep learning section, that if we train our machine learning model based on medical imageries and drug structures, so we can make new breakthroughs in medical technologies and identify symptoms and resources which the human doctors have not been able to do till now. In fact, new breakthroughs have been made but just by using deep learning in the field of medical day by day. And by employing machine learning, we can also optimize our entire pipeline of patient care extremely fast by treating the patients which have very small diseases just by using machine learning models. Now the next field in which machine learning is extensively used in finance. So in algorithmic training, machine learning is already used since machine learning can be used to identify or predict the path or pattern of how the stock is gonna rise and fall. Thus, algorithmic and quant trading experts are already using machine learning models extensively. It can help us in assessing risk of where should we invest our money or where should we not. Now, another interesting field in finance in which machine learning is used in fraud detection. So, as we have discussed in the unsupervised machine learning section, that we can input a purchasing history of a user, purchasing or transaction history of a user, and machine learning can easily identify patterns in it. So if there is any anomaly or outlier in their transaction history in the future, so machine learning can easily identify and notify it. Then we can block those users. Thus we can block all of the bad parties and practices. Now, the next method in which machine learning can be used is e-commerce. In e-commerce, in recommendation system, machine learning is already being used extensively, as we have discussed in the unsupervised machine learning section, that we can label users on the basis of their history and cluster them, and then we can market them the products that only they are gonna buy. Thus, it helps us in creating an extremely personalized user experience. It can also be used in social media platforms to recommend the post so that we can compel user to spend the most amount of time on our platform. Now, the next is manufacturing. So, in manufacturing, machine learning is already being used in order to control the quality. So, on a conveyor belt, we can take the images and feed machine learning models those images and label it that all right, so these are the good products and these are the defective products. So the next time whenever the machine learning model will see a new product, it will immediately classify the defective pieces from indefective pieces. It can also be used in pastry, horticulture, or food related industries in which the defective packages can be identified before even leaving the practices. Machine learning can also predict that when the machines employed in a factory might need the next time of maintenance. Thus, we can schedule maintenance in the downtime where the factory workers are not working. Thus, it can optimize the entire manufacturing pipelines. Now, the next field in which machine learning can be employed is smart cities. So, in smart cities, from smart homes to traffic management to public safety to self driving cars to emergency efficiency, in various fields of smart cities, machine learning can be employed to organize various tasks. Now, to conclude the entire presentation in these slides, we have learned that machine learning is an extremely important tool in order to process big data as it increases our speed and efficiency. It helps the analyst in automating various tasks and gives us quality insights. We have discussed and addressed about the 5 V's of big data and the challenges they provide. We have also discussed about the 5 types of machine learning methods that are used majorly. Now we have also discussed about the real world applications of machine learning in the fields of health and finance. In health, especially health and finance, machine learning can be extremely beneficial. Machine learning has the power to transform how we deal with big data, and thus it is very beneficial in the decision making process. Now that's it, and thank you for listening to me throughout the entire slide.